Hey guys, welcome to section 4, chapter 1 of the geometry program. And in this section, we're going to utilize two postulates, the segment addition postulate and the angle addition postulate. And you will find that they are very intimately related and hopefully not too difficult at all. We're going to draw a line, and we're going to draw it with 3 points, A, B, and C. And what the segment addition postulate tells us is that the segment AB, now I'm not going to draw the line on top, and the reason why is because I'm going to denote distance or length this time, and not specifically the segment itself. I want the length of the segment. So the addition postulate says that segment AB plus segment BC, so this guy plus this guy, is going to equal segment AC, right? So B has to be in between A and C. It doesn't necessarily have to be the midpoint. Occasionally it is. I would say usually it's not. But that when we have a point in between, then one segment plus the other segment is going to equal the whole. All right, that is what the segment addition postulate is. And similarly, when we're dealing with angles, we're going to do the same thing. So if this is angle 1 and this is angle 2, then the angle addition postulate would say angle 1, this is the notation for angle, plus angle 2 would equal this whole thing, let's name it C, E, F. Angle C, E, F. So part plus part equals the whole. Okay? Those are going to be the two postulates that we're working with in this section. Now let's kind of jump in and work some examples. All right. To start us off, let's start very basic on a number line. Go ahead and draw yourself a number line. And we're going to throw some points on there. So we'll say that this is A and this is B. All right, let's call this C and this D and maybe this E. All right, let's just find lengths of these segments. So what's the length of AB? Well, this distance obviously is just 1, right? All right, what's the length of BC? Now we got to count out. This is why we needed algebra as a prerequisite to geometry, right? Because we might be dealing with negative numbers. So we need this distance from -3 to 1, which of course is 4. All right, what about CD? Again, it's just 1. What about DE? There's 2. Okay, well, let's change it up. What about BD? Now I want this guy from -3 to 2. We can count that up and, of course, make that 5. Or what about from C to E? That distance is 3. Okay, so the first part of your assignment is just going to be identifying lengths of segments and comparing them on a number line. So that should be pretty easy. All right, then you might actually have to draw it. Let's say that you have a number line and they give you the points like -6, -4, 1, and 3. And you have to ask questions. They ask you questions about these points here. Like they might ask you, is segment XY the same as segment ZA? So do they have the same length? Well, XY has a length of 2 and ZA has a length of 2. So in this case, yes, they are equal. If one happens to be less than another, like for example, what about XY and YZ? Well, xy is 2 and zy is 5. So in this case, we would say xy is less than yz. Okay, so you're just counting up and comparing. So that's probably not too challenging. All right, now let's say you're given this segment x, y, z, and they give you lengths. For example, let's say this is 9 and this is 4, and they want to know what the length of xz is. Well, remember, part plus part equals the whole, right? So we have a part, that's 9. We have another part, that's 4. Together, that would be 13. So the length of xz would be 13. Okay, what if, I change the numbers there. What if now this is 7 and this is 3, and we want to find the length of xz again? Well, all we have to do is add 7 plus 3 to give us 10. All right, but let's say they give us this is 8 and the whole thing is 15. So let's say xy is 8 and xz is 15. Can we find yz? Well, we can, because we know it's part plus part equals the whole. So in this case, we have 8 plus the part that we don't know. And if you want to go ahead and throw a letter in there, you can. You could also use the segment name that you actually are solving for. Whatever it is that you want to put in there. You could actually make a little algebraic equation here to solve if you don't see it. And then remember, to solve for this, we would subtract 8 from both sides. So our missing piece would be 7. All right, let's do one more like that. What if this is 5 and the whole thing is 19? So in this case, you're looking for xy, yz is 5, and xz is 19. Well, you can set up your equation if you want, right? So this is part plus part equals the whole. So we don't know xy, but we're going to add 5, and together that's going to be 19. Then xy becomes 14. All right, there's one other example of the segment addition postulate, and that's going to go ahead and bring in more of our algebra. Sometimes they're going to give you unknowns represented with variables. So for example, if I had something like, okay, let's call this A, B, and C again. X plus 16. All right, let's say that you have this and they give you AC is 32. Well, we have to set up an equation to be able to solve for x, and then we can solve for our segment pieces if we need to. So remember, part plus part equals the whole. So 3x plus x plus 16 equals the whole. Remember, the whole was 32. All right, now we're going to use those awesome algebra skills like I know you have. We're going to combine like terms to solve this. Subtract 16, and we're going to divide by 4. So if the question asked us to solve for x, we have that. If they asked us for the length of AB, we could simply plug in, right? So the length of AB would be 12. And if they asked us for the length of BC, we could also plug in and get 20. All right, so there could be this scenario. And then similarly, we're going to do the same thing with the angle addition postulate. So they'll give us pieces and we're probably going to have to solve here. We'll call it A, B, and C. We'll call this D. And let's say they give us angle ABC is 70. Angle ABD is 30. And we want to solve for angle DBC. All right, well, a piece, we'll call it 1, plus a piece, we'll call it 2, equals the whole angle, right? So we're going to have to set up another equation just like our segment addition postulate. So I don't know what this guy is. That's DBC. But if I know if I add him to ABD, which is 30, then together I'm going to get 70. And now you'd be able to solve by subtracting 30, and angle DBC is 40. So you're going to apply the same information for the segment addition postulate for the angle addition postulate here. I want to just add a side note at the end here about naming angles in case you're unfamiliar. This is the first time that you've dealt with angles. I feel like this is worth an honorable mention here. So angles can be named in several ways, just like everything else. So this is angle ABC, where the vertex is always in the middle. Also, it can be named as angle CBA. Finally, sometimes you'll see an angle in a figure, and it'll just have letter X, Y, Z, W. And you could name it angle X that way. So just a clarification note about naming our angles, making sure that you get that correctly, because geometry is also about naming things. And if you don't remember, I know they're going to throw a few things at you. Acute angles are less than 90 degrees. Obtuse angles are greater than 90 degrees. And right angles, of course, are 90 degrees exactly. So that was just a couple definitions. I thought it might be worth to footnote here at the bottom. Make sure that you remember so that you can successfully get through this section. Okay, now I want you to finish up your notes, read through the examples, and begin your assignment.